This is the second video on the topic sphere. I was not able to complete 2 points, the tangent plane and the tangent line. So I'm going to take it up in this video. So a little bit about the convention. S equal to 0. So the expression S equal to 0, which is same as S of x, y, z equal to 0. It stands for x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. So if I say S of x, y, z equal to 0, I'm referring to this sphere. And this object is a sphere if it satisfies a certain condition. And the condition was u square plus v square plus w square minus d should be greater than or equal to 0. So we assume all these things. And in the previous video, I was trying to comment on why write something like this. The video broke off, so I'll just mention, I'll repeat my remark, the concluding remark. This will be a preferred way of expressing a surface when you are dealing with level surfaces, which appears in vector calculus. And also it is a very short notation. So instead of writing this long expression, I simply write S equal to 0 to denote the sphere. All right, so let me continue. So in this video, we are basically going to focus on the tangent plane to a sphere. So I have my sphere S equal to 0. From the previous video, we know that once you write the sphere like this, then minus u, minus v, and minus w is the center. And this quantity on the left hand side is the square of the radius. Now, we want to write down the equation of the plane. The plane which is actually the tangent plane. It is not difficult to do so. It is not difficult to write down the equation of the tangent plane if you use a very, very simple and straightforward fact from three-dimensional geometry. Let us look at the join of C and Q and P and Q. This angle will be 90. It will be a nice exercise to prove this by using this definition. I will leave it to you. I will assume that this happens, namely CQ is perpendicular to PQ. And I will use this fact to write down the equation of the tangent plane. So this property is true for any P in the tangent plane. The line PQ will have its direction ratios proportional to x minus x naught, y minus y naught, and z minus z naught. Or maybe if I'm okay, so if I have to do it final minus initial, it will be x naught minus x, y naught minus y, and z naught minus z. Well, let me write it in short as L1, M1, and N1. So these are the direction ratios of the line passing through P and Q. Similarly, the direction ratios of the line passing through C and Q, let me assume it to be L2, M2, N2. All right. Because of this, as this is happening, we get L1, L2 plus M1, M2 plus N1, N2 to be equal to 0. All right, and this implies that, and this implies that. Okay, so I take L1 as x naught minus x, and L2 as okay, so it's all right. All right, so this sign is not going to be important. Minus u minus x naught plus y naught minus y minus v minus y naught plus z naught minus z minus w minus z naught, and this should be equal to 0. Okay. We will rewrite this whole thing in a particular way. So this thing could be written as so let me get rid of the minus signs. So the same equation can be written like this, and now I will write it as expand it and write it as x naught square plus y naught square plus z naught square. So I've taken the terms coming from this and this, this and this, this and this, and I will write u x naught plus v y naught plus w z naught, okay, and plus other terms equal to 0. Let me do it properly. There'll be some visibility problems otherwise. Okay. Let me write this once again. So what I have is x naught square plus y naught square plus z naught square plus u x naught plus v y naught plus w z naught. Okay. And I will throw the other terms on the other side. This is equal to x times u plus x naught plus y times v plus v naught plus w times plus z times w plus z naught. I suppose I've done it right. Okay. Now few more changes over here. Or x naught square plus y naught square plus z naught square plus 2 times u x naught. What I'm going to do is add this thing on both the sides. So I have 2u x naught plus twice v y naught plus twice